several integrals and determine the definite integral. Ready? Okay, 32 on page 395. The integral from 0 to pi over 4 from secant theta, tangent theta, d theta. Okay, so we need to find the antiderivative. In order to evaluate such an integral, we have to find the antiderivative. What function prime is secant tangent? Secant. So this is secant theta from 0 to pi over 4, which means secant pi over 4 minus secant 0, according to the fundamental theorem of calculus part 2. Now I have to determine what secant pi over 4 is and what secant 0 is. Who cares about secant? Secant is 1 over cosine. We don't care. So let me show you that little table that I highly recommend to remember. Nothing else. So let's write it one more time. So this is sine, and this is cosine. This is the smallest angle, this is the largest angle, and pi over 4 is right in the middle. All you have to remember is this. And you always know you start with 1/2. For the smallest angle, you start with 1/2. For the largest angle, you start with the other number, the square root of 3 over 2. So since we're looking at secant pi over 4, all I need is to find cosine pi over 4. Since I'm asked to find secant 0, all I need to remember is what cosine 0 is. Yes, so then this will be 1, and what will this be? Right, exactly, without rationalizing, yes. So that's the final answer, the square root of 2 minus 1.
We just leave it like that?
Yes, absolutely, that's the exact, yes, yes. Very good. Okay.
The square root of 2 or the square root of 2?
There was no, because, very good question. So this, oh, I'm sorry, we're talking about cosine. This, 1 over this number, right, is the same thing with 2 over the square root of 2, but you have to rationalize. And when you rationalize, these 3 go away. Because the square root of 2 times the square root of 2 is 2, and they simplify with 2. So because it's 1 over cosine, it will be the square root of 2 indeed. Questions? Questions? Okay, so let's take a look at the next one. Let's say 40. Same page. The integral from 1 to 2 from 4 plus u squared over u cubed du. I forgot to ask you a quick question. Very important question. Is this function continuous on 0 to pi over 4? Because if it isn't, the whole thing is a lie. This is wrong. So is this function continuous between 0 and pi over 4? Secant is 1 over cosine, no difficulty here. 1 over cosine exists between 0 and pi over 4. And this is sine over cosine, and cosine exists between, it's not 0, I have to say, between 0 and pi over 4. So we are safe. That's the reason why we are allowed to apply the fundamental theorem of calculus. Okay. Now the same thing here. I'm going to ask, is this function continuous? Yes, this function is not continuous at one point, or one x value, or u value if you want. Which one?
Everything.
0, but 0 is not here. So then the function is continuous. Very good. So we don't know how to differentiate something like this. So obviously, I'm going to write from 1 to 2, from 4 over u cubed plus u squared over u cubed du. Luckily, the denominator is just one term, so I can do this. Because if the denominator were 2 terms, I would have not been able to do this. Okay. In the next step, I will completely simplify or change it into something simple. So the integral from 1 to 2 from 4u to negative 3 plus 1 over u du. So now I need the antiderivative of 4u to negative 3. Which function prime is 4 times u to negative 3? So 4 u to negative 2 over negative 2, right? So we are adding to the power, we are adding 1 to the power, and we divide by that number. So let's check if we have any doubts. When I differentiate this, I bring down negative 2, that cancels out with negative 2, and I subtract 1 from the power. Agreed? Okay. And now, what do I do with 1 over u? Which function prime is 1 over u? There is only one function. Thank you, Sammy. Natural log. Well done. We're going to put this in absolute value, and I'll explain in a minute. From 1 to 2. Is that clear? Only natural log prime is 1 over u. And I'll explain why I put the absolute value. Give me 1 minute to finish this, and I'll explain. Is this okay, everyone? Okay, so now we simplify a little bit. Negative 2, u to negative 2, plus natural log of the absolute value of u. I can drop it now because I know it's between 1 and 2, so it's not going to be any problem. There is no need for the absolute value in this case. So I will plug in 2, so I get negative 2 divided by 4 plus natural log 2, but minus when I plug in 1, which is negative 2 plus 0. So when I plug in 2, I get negative 2. 2 to negative 2 is 1 over 4. Natural log 2 minus when I plug in 1, which would be negative 2 plus 0. So then, this is negative 1/2. Natural log 2 is natural log 2 and plus 2. So 2 minus 1/2 is, what is it? 3/2 plus natural log 2. And this is final. Question for you before you ask questions. Can I check this? I have no way. I can only hope. I have no way of checking this. Yes, Eddie, you want to say something? I have no way of checking. The definite integers. So that's why we have to be very careful at every step of the way, slowly but surely, because we cannot check. Are we ready for the first property of the definite integral? That's our next step, or you want to practice more? Oh, we're going to do
One more.
Yes, of course. Yes, I'll let you choose. Yes, of course. Do not choose 43 or 44 because this is the property that I'm going to discuss. And then we can choose either one. So this is very similar to what we just did, right?
Maybe 39.
Yes.
Is that your substitute?
Yes, 39. No, not yet. That's it at the very last section of this course. Not yet. This one is much easier than using a substitution. So you said 39. This is the integral from 1 over the square root of 3 to the square root of 3 from 8 over 1 plus x squared dx. I see a constant as a factor. I'll put it outside. I don't care for it. You can wait patiently. The integral from 1 over the square root of 3 to the square root of 3 from 1 over 1 plus x squared. Sometimes we're going to write this, which is the same thing. 1 over 1 plus x squared times dx, or dx over 1 plus x squared, it's the same thing. I need to determine or find the function whose derivative is 1 over 1 plus x squared. Arctangent. Very good. So this is 8. Arctangent x from 1 over the square root of 3 to the square root of 3. By the fundamental theorem of calculus, I forgot to ask you again. Please never forget to check that. Is this function continuous? Where will this function be undefined? The answer is nowhere. This function is always defined. 1 plus x squared will never be 0, no matter what. So yes, the function is continuous, so we can perform the last step. 8. Arc tangent the square root of 3 minus arc tangent 1 over the square root of 3. And I just want us to go back to this for a moment. Just 1 second. See, I ask you not to remember anything else except this table. But then the question is now, how do I get the tangent? Very simple. Tangent is sine over cosine. When you divide 1/2 over this, it's not going to be a clean, it's going to still have a radical in it, or it will still be a fraction. 1/2 over this, right? It's going to be the square root of 3 over 3. But this over 1/2, it will be the square root of 3. That's all you need to remember, to look at this table, right? So then which angle has tangent the square root of 3 over 3? Is it this one or is it that one? Yes. And the square root of 3 must be this, because when you divide sine over cosine, the 2's go away and you have the square root of 3 left. So coming back to this, what will I write? 8. This is yes, the bottom one, and this one must be pi over 6. But pi over 3 minus pi over 6 is pi over 3, because it's 60 degrees minus 30 degrees. So 8 times pi over 6, which is 4 pi over 3. Can you check? No. We can only hope that we have no errors in there. Okay, very good. Do we feel a little bit better? We're going to have a lot of examples. That's the entire chapter is about this. Should we do another or continue? Okay, so let's look at the first property. Number 1, property of definite integrals. This is the nicest. The area under the graph of f of x between a and a, between 2 and 2, between 3 and 3. What is the width of the interval? What is the distance between 2 and 2?
0.
Of course. There is no distance. Delta x is 0 between 2 and 2. Agreed? Okay, here's the second one. Let's take a look at the graph. No, don't get scared. It's not our long-time friend. So let's say this is f of x. And let's say this is g of x. And this is the interval a comma b. Okay, so what is this area? What does this mean? Oh, this is the area between a and b from g of x dx. Right? Agreed? So the area under the graph of g of x between a and b is nothing else but this area, a1, the integral from a to b from g of x dx. Agreed? Very good. So now what is this? What is the blue area? F of x dx, the whole thing, right? So the property says this. If a function is greater than or equal to another function on a given interval, then what will happen to the integral from a to b from f of x dx and the integral from a to b from g of x dx? They will be in the same relationship. As we notice, the way I graphed it, at least between a and b, f of x is above g of x. So if f of x is greater than or equal to g of x on the interval a comma b, so will the area under the graph of the f of x greater than or equal to the area under g of x. Does it make sense? Yes? Han, is that clear? So the blue area is definitely bigger than the purple area, because f of x is greater than or equal to g of x. So that's why this is the area in blue, and this is the area in purple. Better? Okay, next property. And then we're going to look at those examples. Property number 3. Let's take a look at this scenario now. I have this function, f of x. I have this interval, a comma b. And I have a number somewhere that is c. Can anyone give us this area under f of x? How do I write it?
The interval from A to B of x here.
Excellent, thank you. And what if I do this? Very good. From f of x dx plus c to b from f of x dx. So I can split that integral into as many integrals as I want. So what I'm really saying right now is that the entire area is this area plus this area. Okay, now we're ready to look at an example in which we have no choice, either 43 or 44. You choose. 44. You had it with trig functions for the day. Sorry. I still hope that you copied it incorrectly. Maybe you text me later, so I know. So the integral from -2 to 2 from f of x dx. And we are given a function which is, didn't mean that, a piecewise defined function 2 between -2 and 0, and 4 minus x squared between 0 and 2. Well, here we're asked to find the integral or the area under this function, but this function is a piecewise defined function. It is defined in pieces. So there is no single function between -2 and 2. So I have to split the integral into two, into a sum of two integrals. I have no way of determining this. So then we will write the integral from -2 to 2 from f of x dx equals, and please tell me what to write and what function goes where.
Moving to 0 to dx.
Very good. -2 to 0 from 2 dx, and obviously the other one from 0 to 2 from, because that's what we have, from in parentheses 4 minus x squared dx. Would you like to use the limit of the Riemann sum of these two? Okay. Just kidding. Okay. So then, which function prime is 2?
2x.
Very good. From -2 to 0 plus, which function prime is 4?
4x.
Which function prime is x squared?
-x cubed over 3.
From 0 to 2. Now we have to be careful, remember, we have to plug in the upper limit, the 0 first, and then subtract when we plug in -2. Here we have to plug in 2 and then subtract when we plug in 0. So when we plug in 0, we get 0, minus when we plug in -2, where we have -4. Plus, when we plug in 2, we get 8 minus 8/3. minus, when I plug in 0, I only get 0, so there is no point. So then we have 4 plus 8 minus 8/3, or 12 minus 8/3. We have to multiply the top of 12 into 12 over 1. 36 minus 8 over 3, and I think that that is 28 over 3. So this is the area under the graph of the given function between -2 and 2. Next property, property number 4. We'll come back with more examples, of course. Symmetric interval and even function. These two conditions both have to be fulfilled for what happens next. Can anyone give us an even function? The symbols that you can think of? Yes. Symbols, I would say x squared though. But you're right. Here it is. And this is like -a, and this is +a. So are both conditions fulfilled? Is this function even? Is this symmetric? Is the interval symmetric? Perfect. Let's take a look at the area. I want to determine the integral from -a to a from f of x dx. Is there any way I could simplify the integral? 2 times the integral from 0 to a. Very good. So 2 times the integral from 0 to a from f of x dx. Because these two pieces are identical. Because the function is symmetric. I'm sorry. It's symmetric, yes, it's even. And the interval is symmetric. Why would I ever want to do this? And here's why. When the lower limit is 0, it's always much easier to calculate. Look what happened a few minutes ago when we were asked to determine this. Wouldn't you have preferred this to be 0 and not plug anything? In other words, with 0, this will be 0. In this case, we had to plug in 6, and then we have to subtract when we plug in 2. But here's what happened on the previous example. When I had to any of those limits 0, it made the calculations easier. When I plug in 0, there is nothing. So yes, I do prefer the second presentation, 2 times the integral from 0 to a versus this one. Okay, number 5. We're going to look at a couple in a minute. Oh, I forgot to explain why that natural log of absolute value. I don't want to forget that. Okay, so number 5. Of course, what do you think number 5 will be? If number 4 was symmetric interval and even function?
Asymmetric integrals are not functions.
Yes, no, still symmetric interval. Yes. And odd function. Both conditions. Can anyone give us an easy to work with? Don't upset Greg, don't give me a trig function.
X.
Cubed. Let's look at x cubed. Here it is. Very good. So this is x cubed, a little flatter here. Good. Is this an odd function? Yes. I'm going to choose a symmetric interval. Of course, -a. Both conditions are fulfilled. Odd function, symmetric interval, and I want to determine this area. I want to find the area between -a and a from f of x dx when the function is odd. What do you think the answer is? Of course, it is 0. The areas are equal, but this is a negative area and this is a positive area, so the answer is 0. So both conditions have to be fulfilled. Odd function and symmetric interval, the answer will be 0. So here's a simple example. The integral from negative pi over 4 to pi over 4. Oops. From negative pi over 4 to pi over 4. From x cubed cosine x dx. So here's what goes to my mind when I see an integral like this. Number one, is the function continuous between negative pi over 4 and pi over 4? Yes, the function is continuous. Number two, I see a symmetric interval. Then immediately ask myself, is the function odd or even? Because if it's odd, the answer is 0. If it's even, I can change this from 0 to pi over 4. So, is this function odd or even? What do we know about cosine? Is cosine odd or even? Even. There are only two trig functions that are even. Cosine and the other one that only has cosine in it, which is secant. So cosine and secant are even. So this is even. But what about x cubed? So yes, an even function times a odd function will always give us an odd function. So this is odd, symmetric with respect to the origin. The interval is symmetric, and the answer is 0. Okay.
So because the whole thing is odd, it equals 0.
Yes. 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 Okay, so now let's go back to what I forgot to mention. Let's take a look at this function. For a moment. Well, in order to look at this function, I have to first start with the absolute value of x. I'm going to refresh your memory. The absolute value of x is, if you remember, if not, I'll refresh your memory. Either x if x is greater than or equal to 0, or negative x, very good, when x is less than 0. So now we want to look at the natural log of the absolute value of x. Well, there are two possibilities. Natural log of x or natural log of negative x, but I have to be careful. First of all, I would like to put this in parentheses, but then I have to make sure that knowing that the graph of natural log has a vertical asymptote where at 0, I cannot include the equal symbol here. So this is x greater than 0 or x less than 0. Now, in the next step, I want to differentiate this. What would you say? Natural log prime is, and natural log negative x prime is, times the inner function prime, which is negative 1, 1 over x. So therefore, when we integrate 1 over x, what do we get? When we integrate 1 over x. Going backwards now. So the integral from 1 over x dx will be natural log of the absolute value of x plus a constant c. Do not worry about this whole thing. Just, I want you to worry about that. That's the reason why every time we integrate 1 over x, the answer is not natural log x, but it's natural log of the absolute value of x. And we showed why. Because when we differentiate natural log of the absolute value of x, no matter what, we get the same answer. I didn't want to forget to show that. Any questions? Any questions? Okay. I know we have about 10 minutes left. I would like us to look at a property. We have not discussed this property yet. These two, actually. So I'd like us to maybe look at 56. Let's read the problem. Use the properties of integrals to verify the inequality without evaluating integrals. We cannot even do that. This we cannot even determine by hand. This one we may, but not this one. So here we're not asked to evaluate this. We're not asked to evaluate this and say that this is 1 and this is 2, so 1 is less than or equal to 2. We're asked to use the properties of integrals to show that. So this is 56 on page 384. So it's the integral from 0 to 1 from the square root of 1 plus x squared dx less than or equal to the integral from 0 to 1 from the square root of 1 plus x dx. And no, we cannot look at it and say, well, it's obvious. No, we can't do that. We have to show why. And remember what the idea is here on such a property or such an inequality. We want to show this. If I manage to show this, that f of x on the given interval, a function that we will talk about in a moment, if I manage to show that f of x is less than or equal to g of x, then the area under f of x between 0 and 1 must be less than or equal to the area between 0 and 1 from g of x. That's one of the properties we looked at a minute ago, right? So then what I have to do is just start with x. That's what this is all about. I'm specifically told x is between 0 and 1. So if x is between 0 and 1, let's analyze just this piece. Which of these two is smaller? Remember, we are talking only about numbers between 0 and 1. Like 0, 1/2, 1/4, 1/16, 1/8, 1/9, 1/15, 1. So which of these two? Is it x squared which is smaller, or is it x which is smaller? So let's just pick 1/4. Well, if this is 1/4, this is 1/16, right? So 1/16 would be smaller than 1/4. Only for numbers between 0 and 1. If this is 1/3, then this is 1/9. Well, 1/9 is smaller than 1/3. So I'm confident that I can put this inequality symbol between the two for x between 0 and 1. Agreed? Okay. So this is fine, but I'm not there yet. What should I do to both sides of this inequality to get closer to what I'm looking for?
Add one.
Of course, thank you, Eric. So we're adding 1 to both sides. So then we have 1 plus x squared is definitely less than or equal to 1 plus x. I only added 1 to both sides. Now, I'm going to do something that I normally say don't. But since these are positive quantities, if I have 2 less than or equal to 3, the square root of 2 will be less than or equal to the square root of 3, only because they're positive numbers, right? So then I can apply the square root to both sides. So then, if these two are in this relationship, then these two will stay in the same relationship. So then that was what I was trying to do. I was trying to show that this function, f of x, is smaller than or equal to this function, which is g of x, on the interval 0, 1. Once we show that, we're going to apply the previous property and say, okay, well, if that's the case, then the integral from 0 to 1 dx, the integral from 0 to 1 dx must be true. This relationship must be true because the functions are one below the other. So then the area below the first one will be smaller than the area under the second one. So basically that was all we were asked to do. Any questions? Okay, I would like to just mention one more property. Oops. I think we reached 6. Yes?
Yeah.
Okay. And here it is. The integral from a to b from f of x dx is the same with the opposite of the integral from b to a from f of x dx. And you can say, okay, that's fine. So what? We need this for fundamental theorem of calculus part 1. So if we swap the limits, then the sign changes. Last one, 26, on page 395, I promise. Oh, yes, I remember what it was. From -5 to 5 from e dx. Okay, e is a constant, has no place in here. Which function prime is 1?
X.
Very good. From -5 to 5. So e, and what do we have in parentheses? I plug in 5, and I get 5. Minus when I plug in -5. So 5 minus -5 is 10 times e. I want to illustrate this so you understand, and we will look at other examples next time. So here's the situation. E is a constant. It's not e to the x. So 1, 2, 3. So this is e. Y equals e. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. -5 to 5. Can anyone give us this area? It's a rectangle. What is the width?
10.
What is the height?
E.
That's how we get 10e. Width times height. That's how we get the 10e.